year, and we'll talk about why that is. So just a few things to cover. We're going to go through a brief introduction into what the technology is and a little bit about how it works. And then we'll talk about how we actually do the people counting and why, and what it actually looks like to implement a solution like this. And then we'll compare it kind of with some other technologies. So if you think about this from an engineering perspective, there's a lot of ways to solve this problem. LiDAR is just one of them, to be completely honest. So we'll talk about kind of how we compare with those other technologies so that you understand, maybe what the benefits of using LiDAR are in this application. And then if you've got questions, I would appreciate if you hold them to the end or try to chat them into Microsoft Teams if you are worried you're not going to be able to remember it. And we'll try to address those then at the end. So current situation, I'm sure we're all very tired of talking about this at this point, but it's still a very current event where we're dealing with this pandemic globally. And this is an issue that isn't just affecting the United States. This is affecting everybody, and it is a problem that presents, some opportunities for SICK to help, essentially, because we are a technology company, and so we're able to use that technology in a variety of ways. And in our case, we choose to do it as much as possible to help, keep people safe, help our governments try to figure out how to actually implement some of the rules that they've come up with, and just trying to use technology where we're able to assist in this process. So there's a variety of ways that our governments have set up to try to keep people safe. Some of them are pretty simple, like just staying away from each other. Some of them are a little more complicated, like trying to keep people within a certain space for a certain amount of time, or prevent them from being in that space for too long. But maximum capacity is one that is really pretty difficult to enforce, because we've got public spaces, and within those public spaces, we can calculate what a safe amount of people or what is safe to have a certain number of people in there. But to actually enforce it, you end up having somebody sit out there with a counter or a piece of paper and a pencil, trying to figure out how many people are in there. It's a pretty complex thing to actually implement when you're talking about maybe 100 people or 200 people in a building. So we basically have developed a solution that makes that process a little bit easier. And as I said earlier, this isn't new. We've actually been working on this for some time, but because of the situation that came up in 2020, we really fast-tracked this development to make this product a reality as quickly as we possibly could. So what we ended up with is what's called the people counter, which is a LiDAR-based sensor. If you're not familiar with LiDAR, it's basically uses lasers to do distance measurement. And then based off of what those distances are, well, like I said earlier, we can do a wide variety of things. In this case, we look at those distances and basically determine what is a person and what is not. And then we determine the direction of the person and basically use that to increment a counter. So we'll talk about that a little bit further, but these are just some of the main kind of benefits of the people counter. Probably one of my favorites is that this is an anonymous solution. So it's 100% anonymized, right? When we compare that to, say, a camera, for example, there are privacy concerns anytime you put a camera anywhere. And in a lot of situations, there's places that you can't put a camera, for example, outside of a restroom, or you can't put a camera in a secure area, for example, a bank vault or something like that. There's going to be regulations about what cameras you can put in there and why. So we can have a solution that basically doesn't track any kind of personal information, because all it's doing is looking at those distances that it's calculating. So it's a great solution. So far in our testing, we've seen counting accuracy greater than 98%. So if you shoot 100 people through there, it's going to see about 98% or greater in any situation. And we'll talk a little bit more about that, but it's a very, very robust technology. So what does that look like? Well, it looks like this on the right. On the right, we've got a short video that basically has the people counter mounted above our entryway into our canteen in Germany. So this is actually, it's still installed up there because we are actively trying to monitor the number of people that go into the canteen for lunch, right? Because Germany is under a lot of the same restrictions that the United States is. So if I play the video here, you see, count at the bottom says 30 out of 50. There's 50 people allowed in there. There's 30 in there at the moment. So that didn't work. Try that again. There we go. So when our friend walks out the door, we see the counter come down. When our friend walks in the door, we see the counter go up. So as they walk back and forth, it's basically just monitoring that and counting the number of people that are going in and coming out. It does that again completely anonymously. It's not recognizing them and doing facial tracking or anything like that. It's just counting the number of people that go in and out. Some people have asked us how this works if you've got a large area. We've got a situation set up called master-slave mode, where we can basically set up multiple devices. So if it's a single-use situation where we've got a small entryway, we can just basically set this up and program it, and it's good to go. It's a very plug-and-play type solution. If it's a much wider area, we can actually set up 2 side by side, or 3 side by side, or 4 side by side. However wide we need to go, we can cover that area using our master slave mode. And we can also set it up. These are all showing in a line side by side. We can also set this up pretty much anywhere. So if you've got an entryway on one wall and the exit, on some other wall, facing the entryway, we can set it up that way as well. It just needs to have some kind of Ethernet connection to make that master-slave collaboration. This is the operating principle, the way that the set actually works. And the way that actually works is that the MRS 1000 people counter is basically a 4-layer LiDAR device. So if you consider LiDAR from its roots, it's basically a 2-dimensional plane, right? Which would just give you a single layer of detection. But with the MRS 1000, we basically have 4 layers, and they're separated by a slight angle. So they're kind of represented here in the bottom left with A, B, C, D. So those 4 layers, the way that they're oriented means that as you walk into the room or as you walk through the door, you break those layers in succession. So if you're walking, say, into the room, you're going to walk through it and it's going to go A, B, C, D. If you're walking out, conversely, it's going to go D, C, B, A as you walk out of the room. And so as you're walking through there, you're just breaking those layers, and all the people counter is doing is basically determining your direction based off of which direction you break those layers. That gives us a really cool way to figure out which way people are going, but it also gives us the ability to kind of rule out the exception cases. Like, for example, if our friend down here on the bottom left walks in and then realizes he forgot his mask in the car, he can turn around and go back out. As long as he doesn't break that D layer, we don't count it. Somebody has to pass all the way through before we actually say, yes, they've entered. Now, if he does break D and then he turns around and goes back out, we can still say, okay, he entered briefly and then walked back out, because then it went D, C, B, A as he walked back out the room. So there's that. And then we're also not just looking at him breaking the plane. We're also doing a pretty cool analysis on the actual contour as he walks underneath it. So if you're not familiar with LiDAR, this might be a little confusing, but in short, basically these red dots that you see up here in the ID frames up here, these red dots are just the individual measurements that we're taking with our LiDAR technology. And they represent basically the contours or the shape of the person. You can kind of see here, especially in the middle one, ID6, you can see a head and some shoulders pretty clearly. That is what we are looking for to determine that, yes, this is a person. So we actually used a deep learning algorithm to basically look at 1,100 different contours of people so that it could determine more accurately what an actual person looks like. And it does that very reliably too. So what that gives us is an ability to filter out other things, like for example, if somebody's wearing a backpack on their back, it's not going to see the backpack and go, oh, there's somebody following him. Or if they're pushing a shopping cart, it's not going to see the shopping cart and say, oh, that's a person going through there. It's a very intelligent system that is really designed very well just to look for people and count them as they go through. We put a lot of thought into making sure that this is robust. So what we've seen so far, as I said earlier, is that 98% or greater detection rate as people walk through. So to actually put this in place, we've got a few basically rules that we'd like people to follow. Essentially, it just has to be mounted between about 6 feet and about 11.5 feet above the ground, which is pretty common, I would say, because you're not going to mount it lower than 6 feet. That's you're going to have people with head injuries as they walk through the door, and you could mount it higher than 11.5 feet, but you're going to have issues with resolution because the higher up you go, the more it has to work to try to figure out what a person is as it travels underneath it. So we recommend basically bringing, if you've got a ceiling or something higher than 11.5 feet, just bring a rod or a pole or something down to mount to so that it's within that 11.5 foot boundary. And as long as you do that, it basically is able to monitor roughly the same distance or the same width underneath it. So if you mount it about 11.5 feet high, it should be able to monitor about 11.5 feet wide of an opening. Now it says here, children won't be detected, limited around 4'7". That actually, you're basically the first people in the country to learn about this, but we have actually been able to refine our algorithm so that now we don't have issues with people under 4'7". The issue at the time that this was made was that we couldn't test anybody under 4'7" just due to the restrictions that were in place in Germany. We couldn't get a group of people together that could go through here and test this and make sure that it worked. So since then, we've been able to work up a test to get people under 4'7" through our testing facility so that we can make sure that, yes, it's counting them accurately. So that bullet point is no longer the case. Now, if you've got a situation where you've got children, which, at the time we weren't too concerned because there's not a lot of industrial applications where you've got children running around. But if you do, if it's, a theme park or a school or something like that, we now have the ability to detect children as well. So that's the basic concept, is that if you mount this thing above a doorway, between 6 feet and 11.5 feet, you really just put it in place and it starts counting. There's very little configuration required. There is a bit, though, but you'll find it's extremely easy. We basically have a teach-in functionality. So this is the web page that's hosted on the device. So when you take it out of the box, you plug it in and hook up the Ethernet cable, and then open up a web browser, and you just go into the IP address of the device, and this is what you get. This is the teach-in screen. It's very simple. All you really have to do is there's a button up here that says counter active. You can't teach it when the counter is active. You have to basically bring it offline or turn it off, however you want to phrase it. So you click that button and it turns off. And then these blue bars that are basically tied to the slider, you slide those so that you define your actual area of interest. So if you've got a large opening and you really only care about people walking, through a certain portion of it, like for example, if you've got like a security way, where you've got, a metal detector and you want to count people going through the metal detector, but you don't care about people that aren't walking through the metal detector for some reason, you could define just that metal detector area using these blue bars. Anything that passes outside of the blue bars, we're not going to count. Anything that passes through the blue bars, we are going to count. So we just define that. We tell it where exactly the door is within its field of view. And that's the major thing you have to do. It won't work very well if you don't do that. But outside of that, there's a couple of other things. You can set this floor, this red line here is basically the floor. You can set that so that the angle is correct. There's a slider that you can use to basically give it an offset of 1 or 2 degrees to make sure that it's level. And that just helps the algorithm work a little bit better if your mounting isn't 100% perfect. So there's the orientation offset. You basically slide that so that that floor is level. And then outside of that, there's not much else you have to do. This initial value in and initial value out, these are values that you can put in so that, for example, if you installed it and you know that there's already 10 people in the room, you could set that to 10 so that that count is already preloaded in there, so that when people walk out, it doesn't start assuming that they're negative people or something. So that's essentially it for the setup. If you have a situation where there's going to be people walking in, but you want that to count as the opposite, for example, if you mount it backwards, that's fine. You just basically have to click the switch direction up here, and the switch direction button will go ahead and invert the count. Very simple. If you've got multiple devices, like I mentioned earlier, if you've got a large area to cover or multiple walls that you want to try to monitor, you can collect data of multiple devices. And basically by clicking this device as the master, it will assume that this is the master and that anything connected to it is the slave. And that would just basically set up your multi-device network right there. Once it's all set up, you put it back into counter active mode, and it just starts counting. So this is the main counter screen where if you just want to know how many people have gone in and how many people have come out, this is the screen that you can go to. It also shows you a history. So it does basically a total count of every day. At the end of the day, it loads this up and says, okay, on May 6th here, we had 343 in, 345 out, so that you've got that historical information available as well. Probably the more applicable mode is called room capacity mode. And so if you go to the room capacity page, you see this, and it's basically a preset value which you've put in there. With our canteen earlier, we had 50 people allowed, right? So we can put 50 in there as the capacity. And then the persons inside is basically your current count. So here you can manipulate that if you need to. Again, if you've got a situation where you already had 10 people in there when you turned it on, you could enter in 10 in here so that it would know how many are currently in there. And then beyond that, all it really is just a screen that shows this green bar with a current count out of however many are allowed in there. And then as you approach that, you can set thresholds so that it can turn yellow as you get close to the threshold, to the capacity. And you can also have it turn red once you hit capacity. So that now you've got a display if you want to know exactly how many people are in there, as well as how many people are allowed in there at any given time. You got that information as well. So I kind of already went through this, but essentially to set it up, you mount it in place, you connect the power supply and the Ethernet, and then you go to the Teach-In tab and just start setting it up. There's a walkthrough here, which I've already gone through, but it's available if you need to set this up on site. And the counter information as well. There's really, like I said earlier, there's really nothing you necessarily need to configure here. Okay, so all this information is great. It's all accessible over Ethernet. However, if you've got an external display device, anything you want to try to interface with, we also have that functionality available as well. So if you see here in the middle, this connection type IO, this is a connector that we've got in the middle here. And on that connector, we basically have a whole bunch of inputs and outputs that we can coordinate. So here we've got a light stack. This light stack is available that's pre-wired that you just plug into the back of the people counter, and automatically, I talked about the red and the yellow and the green screen earlier. That information is automatically sent to this stack light, the signal lamp. So if you've got a low capacity, if you've got 1 out of 50 people in the room, that green light's going to light up. If you get close to the capacity of the room, that yellow light's going to light up. And then if you're at capacity, the red light's going to light up. And that's just a quick, easy way to signal externally what the current capacity of the room is, but it's not the only way. If you've got another type of light stack, that could easily be wired up to this as well. If you've got a 7-segment display that has a counter function where you can basically just input a signal and it increments the count, we've got the ability to interface with something like that as well. We sell this all as a pre-made set too, so you don't have to buy everything individually. You can basically set it up so that by buying this part number, it comes with the people counter, it comes with the interface box that basically allows you to bring in your own cable, and then it would come with the stack light as well. And we've taken it a step further too. All of this information is also available with Ethernet commands as well. And so that can be paired with either your own controller, if you've got a PC on site that you want to try to interface with the people counter, that can be done. And we also have, this is called a TDC box, which can basically be set up to take the signals, take the information from the people counter, and create basically a dashboard that's accessible pretty much anywhere. So that option is available as well. I mentioned earlier that there'd be, comparison of this with current technologies. I'll just jump into this YouTube video real quick. It's a nice video that we put together that shows essentially what the differences are. So I'm just going to talk over it. I'm not 100% certain if you're getting audio now or not, but if you are, it's just a song. But we know at this point that we've got a variety of reasons why people would want to know how many people are in a room at any given time. So we've got the possibility of employing somebody to stand in front of the door, or there's other solutions out there. Like this is probably the most simple. It's very similar to say the brake beam underneath your garage door. I'm sure there's nobody there when the garage door shuts. Very similar concept, just using light to basically say, is somebody passing through or not? But there's problems because, for example, if two people walk side by side, or if somebody's pushing something through, that can be detected, cause miscounts. It also has to be mounted right there at person level, so it's bumped by people as they're traveling through. One of the benefits of the people counter is that you can mount it overhead so that it doesn't get damaged. It's also designed, like I said earlier, to basically look for only people, not anything else. So it's up there out of harm's way. People walk through, they're not going to bump it. And as it'll say here in a second, even if people walk through side by side, we see two heads with two sets of shoulders. We say, okay, that's two people. If people are walking through also simultaneously and they're passing, one going in and one going out, not a problem. And believe me, we've tried to trip this thing up. It is very, very accurate once it's installed and set up correctly. And if you've got a large area, we can actually cover two doors simultaneously, which again, if you've got, a laser-based system looking for just the presence or absence of people, it's going to be difficult to do two doors with a system like that. So again, just wanted to show one more time these features of the people counter. Basically, it's just designed to look at the current utilization of space. It's very accurate, very robust, and if we've got a situation where there's low light or high light, where there's a lot of sun, we don't have issues with that either. We can actually operate this thing outdoors if we needed to. So it's very, very interesting technology. very applicable to our current environment. And if you've got any questions on it, I'd be happy to try to answer them. Now, if there aren't any questions, Maria, should we wrap it up?
Aaron, I do have a question.
Okay.
Have you considered trying to use this technology in a drive-through operation to count vehicles? Is that something that would be possible?
So we've definitely considered it. Good question. And nearly every time I give this presentation, somebody will say, well, can it count cows? Or can it count, widgets traveling down a conveyor belt? Or can it count cars? And the answer is no, it can't right now. It is a people counter, so it counts people. But that is definitely a consideration. And well, I'll answer it two ways, because in one way we're looking at applications like that, and this is a pretty adaptable technology. So really all we would have to do is take our algorithm and reteach it to look for cars instead of people. And that would be definitely something we could look into. But it's also the technology itself, just the LiDAR could be set up pretty easily just to do counting without even really having to teach it an algorithm. If you've got cars that are separated and they're probably not going to back up or anything like that, it'd be fairly simple to just set up a device like the people counter to do that type of counting.
Okay.
Yeah.
Aaron, there's a question here. Does weather affect these locations?
Good question. So the short answer is no. Of course, there's going to be a point where, if the sensor is covered in snow or something like that, it could have issues. But we use what's called multi-echo technology in our LiDAR, which basically means if we've got a situation where there's precipitation or fog or something like that, those weather events can cause multiple reflections to come back into the scanner. And we actually collect all the reflections and then make a determination on what the most likely one is. And that helps us to filter out all kinds of rain and snow in most situations. So if you've got an outdoor application where there could be rain or snow, we'd want to take a look at the application individually, but there shouldn't be an issue because we have that multi-echo technology.
Anybody else? Oh, got one more.
Good.
Brian's asking, what about schools?
What about schools? That's a good question. So we are definitely in talks with schools, not so much in the US, but there are several interested parties in Europe that are looking at it. And I think the question is, what's the use case? So we want to know, at this point, how many kids are going into a school so that we know the current capacity, like I talked about. But there's also other people who are asking about putting them in schools in order to verify that in the case of a fire, everybody's gotten out of the building. And that's one where I usually red flag it and say, let's not, because we're talking about a detection accuracy of about 98%. So we don't want to have to worry about that extra 2% because we put it in a safety critical type environment. But absolutely in schools, now that we've got this functionality to detect people under 4'7", that's definitely somebody that we're going to be talking to here in the U.S. as well.
All right, got another question for you. Does the speed of the person walking or running affect the reliability of the count?
I can't say no, because I do know that if somebody is absolutely bolting through, and I'm talking like a dead sprint, we could miss it. I've tested it, and when you really travel through as quickly as you possibly can, it could miss. And so for most purposes where people are traveling, even jogging through isn't a problem. But if somebody absolutely wanted to get through and it was in a dead sprint, it could miss them because of the way that the technology works. We're not scanning, 100 times a second. We're scanning about 25 times a second. So it's possible, just for your information.
Okay. Anybody else have a question for Aaron? All right. Aaron, do you want to put up your, okay, thank you.
There you go. Yep. So if you've got any further questions, if you think of something that we didn't cover, feel free to reach out to me or Dennis. Either one of us would be happy to answer your questions.
Thanks, Aaron.
Thanks very much, Aaron. And yeah, anybody wants